parallel lines and transversals, solve for the indicated values. Okay, now make sure that you're doing this after you completed the foldable and you've reviewed your parallel lines cut by transversals. So after we've done that, I'm going to take a look at my picture. Do you see these two big red arrows? That means that these lines are parallel. Then I'm going to look at what I have, and I have this angle over here, and I have this angle over here. Both of these angles are on the exterior of the parallel lines, because right here, this is the interior, which means this is the exterior. Okay, so they're on the exterior, and then also one is on the left and one is on the right. So they are opposite sides, so we know these are alternate exterior angles. Now, if you go look at your foldable or your notes, alternate exterior angles are congruent, meaning they have the same measure. So what we can do is we can take 3x minus 1 and set it equal to 38. Then we're going to solve that for x. So I'm going to add 1. That's going to get me 3x equals 39. And then I'm going to divide that by 3, which is going to give me x equals 13. Now, once I know that x equals 13, that was the first indicated value. And then the other indicated value is, well, what's the measure of this actual angle? So I can either substitute 13 in, or, because I know these are congruent, I can just say, well, it's 38. Next one. Take a look at your parallel lines. Take a look at your transversal. Now, if I'm looking at this, it looks like they are on, if I'm looking at the transversal, they are on the same side of the transversal. And then it also looks like one is on the exterior and one is on the interior. So specifically, those are corresponding angles. Now, we know corresponding angles are congruent, so once again, I can say x squared plus 5 equals 6x. Now, solving this one is going to be a little bit harder because we have an x squared. So we have to remember how to solve a quadratic. In order to solve a quadratic, I'm going to get this first equal to 0. So I'm going to have x squared minus 6x plus 5 equals 0. Now, option 1, we could use the quadratic formula. Option 2, we could probably complete the square because the leading coefficient is 1 and the middle term is even. Or I think this guy might actually factor easy. So if I'm factoring, I'm going to multiply the last number by the first number. So 5 times 1 is 5. The middle number is negative 6. So we have to multiply to 5, which could be like 5 times 1. But it has to add to negative 6. So what if we made it negative 5 and negative 1? So then I know that this is going to factor into an x minus 5 and an x minus 1. Then I can use the zero product property and say x minus 5 equals 0 and x minus 1 equals 0. Solving both of these, I would add 5. So x equals 5. And then on this one, I would add 1. So x equals 1. Now, my first thought would be, I have 2 answers. I hope they both work. Because if we're dealing with angles, okay, if you substitute something back in and get a negative angle measure, that's not good. So if I take 5 and substitute it back in, let's see. 5 squared is 25 plus 5. This would be 30 degrees. Well, if I take 5 and substitute it back in, 6 times 5 would be 30 degrees. Okay, that looks pretty good. Based on the picture, I mean, obviously the picture's not drawn to scale because this looks like an obtuse angle, but we're just going to go with picture not drawn to scale, but this is a good answer. Next one, if x is 1, well, 1 squared is 1 plus 5 is 6 degrees. And then 1 times 6 is 6 degrees. again, it's kind of small because it looks like an obtuse angle, but 6 degrees is congruent to 6 degrees. Also a good answer. So this one actually has 2 answers. Next one. Here's our parallel lines. We have the angle right here, and we have the angle right here. Those are both on the interior, and they're both on the left side. So these are same side interior. And if we look at the relationship for same side interior, they are not congruent. They are supplementary, which means they add to 180 degrees. So I can take the 4x plus 20, I can add it to the 12x, and I know that they're going to add up to 180 degrees. Then we're going to take our 4x, add it to our 12x, 16x plus 20 equals 180. We're going to subtract 20, which is going to give us 16x equals 160. Then we're going to divide by 16. X equals 10. Then if we substitute these back in, let's see. 4 times 10 plus 20 is 40, 50. This is 60 degrees. Then if I take 12 times 10, that's 120 degrees. And if you add 60 plus 120, you get 180, which is what we wanted anyway. Okay, this one. First of all, do we remember the name of this shape? And the name of this shape is a trapezoid. So a trapezoid has 2 parallel lines and then 2 other sides that do something different. Okay, but it's still, if we're trying to figure out the measure of these angles, 2 parallel lines cut by a transversal, and I'm looking at this angle and this angle. Both are on the inside of the parallel lines, and on the same side, they're both on the left of the transversal. So once again, same side interior. And we know that same side interior are supplementary. So we can say x plus x minus 44 equals 180. Combine your x plus x, 2x. Minus 44 equals 180. Add 44. So 2x equals, let's see, 180 plus 44 is 224. Divide by 2. X equals 112. Okay, so if x equals 112, we're going to come back. I know right here, this is going to be 112 degrees. Then we're going to substitute 112 here. So 112 minus 44 is 68. And then if we were to check that, 68 plus 112 is 180 degrees. So we're all done.